Good morning, everybody. So, today we are going back to work we had been doing before the school shut down. That is looking at the topic of patterns. Now, previously, when we've been doing these patterns, we've been looking at specifically linear patterns. That is a pattern which will go up by the same amount each stage. So, the number of blocks or numbers or whatever it was went up or down by the exact same number each time. Alright? So if you were to graph that, you would have gotten a straight line. But today, as I said, we're looking at something different. So if we look at this pattern here, I have the numbers 2, 5, 10, 17 and 26. Well, if we look at the difference between any of these numbers, i.e. how much it goes up, we see that the difference between 2 and 5 is 3. The difference between 5 and 10 is 5. The difference between 10 and 17 is 7, and the difference between 17 and 26 is 9. This is what's called the first difference. Now, so far you've been able to say that if the first difference in a pattern is the same, it's a linear pattern. This pattern, they're not going up by the same number each time. So we straight away know it's not linear. But can we figure out what type of a pattern it is? Well, yes, we can very easily. We now look at this difference between these numbers here. The difference of the first difference. 5 and 3 is 2. 7 and 5 is 2. 9 and 7 is 2. So this is what we call our second difference. And in this case here, we can see that the second difference of our pattern is the same. If I have a pattern and its second difference is the same, it is called a quadratic pattern. Okay, so we now have a new type of pattern. It's not linear, it is quadratic. So all of you take this down with me right now. If I have a pattern and its second difference is the same, it's called a quadratic pattern. And you should take this whole example down. Now the great thing is with this video, I'm going to wipe this out straight away, but you can pause the video when it's up on YouTube. So, let's look at another example. 5, 7, 10, 14. So first we get the first difference. The difference between each number. The difference between 5 and 7 is 2. The difference between 7 and 10 is 3. The difference between 10 and 14 is 4. So this is our first difference. Now we can straight away see two things clearly. One, our first difference is not the same. The numbers that each stage is going up by is different to the previous stages. But we can also straight away see something else. The second difference is going up by the same amount. So this is yet again another example of a quadratic pattern. So then you might ask yourself, well, what if I was given a pattern, is there any way I could work backwards to see if I could find an example? Now let's see if I can find one here in my book. Let me think. Well, you could be given a question where, so let's say I've got a pattern. 3, 7, blank, blank, blank. Okay? And I'm told in the question, this is a quadratic pattern. I'm told that straight away. And I'm being asked to find the other numbers in my quadratic pattern. Well, in order to do that, I would need a bit more information. They'd have to give me some more information, all right? Actually, specifically, now that I think of it, yeah. 5, 4, 9. Let's say they've given me this many numbers. Okay, and they said find the rest of the sequence. How could I do it? Well, let's look here. Okay, the first difference here is 4. Yeah? The second difference here is 9. They've told me in the question this is quadratic. So when I find the second difference here, that is 5. Now, I can't do this question unless they told me beforehand it's quadratic. But they've given me 3 numbers, 3, 7, 16. Find the next 3 terms in this quadratic pattern, quadratic sequence. This is how we do it. I find out what my second difference is. It's 5. So every single time, the second difference is going to be 5. Well, if my second difference is 5, what number would go here? Simple. 9 plus 5 is 14. Okay? Well, if this number is 14, what number would go here? Well, 14 plus 16 is 30. Now do the same thing again. 14, 5 is 19. What number goes here? 30 plus 19, 49. And then last one again. 5 plus 19 is 24. 24 plus 49 is 73. And that is how you would find the further numbers in a quadratic sequence. Okay? So, recap. They give me 3 numbers. They say it is a quadratic sequence. Okay? Quadratic sequence, second difference is the same. How do I know? Because I literally just said it and you've all got to burn into your memories now. You have to know this. It's as simple as that. This is the rule for this type of maths. Quadratic sequence, the second difference is the same. Like in our example over here. Find the next 3 terms in the sequence. Well, first of all, I need to find out what the second difference was. So, 3 plus 7, or 3, the difference between 3 and 7 is 4, the difference between 7 and 16 is 9, the difference between these two is 5. So I now have my second difference, okay? Once I have the second difference, I work backwards. 9 plus 5 is 14. 16 plus 14 gives me my next number in the sequence, 30. 14 plus 5 is 19. 19 plus 30 gives me 49. That's the second term that I need to find my sequence. 19 plus 5 is 24. 24 plus 49 is 73. And that is how you do a question like this. Okay? I have one more thing that I want to discuss. And then this video will be done for the day. So, the third type of quadratic, or not quadratic, the third type of pattern that we could get. Here's one here. Now, let's look at it. The first difference. 2, 4, 8, 16. Anybody notice anything here? The first difference is the same as some of the terms in the pattern. And if we look again, the second difference. 2, 4, 8. The first difference is not the same, the second difference is not the same, so it is not quadratic. Okay, so what is it? Well, if we look at these, I could write any one of these as 2 to the power of n, where n is the stage number. So, for the first stage, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8. These are all powers of 2. When you get a question like this, where it's a power is the pattern, it is called exponential. It is an exponential pattern or sequence. Now, it would be enough in a question for you, if asked, identify the type of sequence, to say the first difference is not the same, the second difference is not the same, therefore it is not linear, it is not quadratic. You wouldn't even necessarily need to prove it's exponential. If you said it is not linear, it's not quadratic, that would be enough. Okay? So that's my video for today. Quadratic sequences or quadratic patterns, that's what we're on to now. How you know if it's quadratic? You prove that the second difference is the same. Okay? The questions I want you to do are going back to the chapter, patterns and sequences chapter, and doing the questions in the other sequences chapter, okay? So basically, you're skipping past all of the shape questions that were in the book, okay, for the matchsticks and stuff here. So it's other sequences. Now, I don't, as you know, my book is a different edition here, so it's a different page number, but the chapters are all still the same. Okay, so we are at patterns and sequences, and the section, in my book it's section 6. I think it's section 6 in yours, not sure, but it's called other sequences. If you're unsure, when you're doing your classwork tonight or today, if you're unsure, take a picture on your phone of the page you're on, email it to me at my email address that you all have, and I will be able to tell you yes, they're the correct questions or not. You're on the right section, or no, go to the next section of the chapter, the previous section, whatever. So if you're not sure, you email it to me. Okay? Tomorrow morning I want pictures of your work from your copies. That's fine enough, showing me that you have actually been doing this work. I'm trying to correct through them as quickly as I can. It's a bit slower this way. The main thing is showing evidence that you're working. Okay? So I'll be uploading this on YouTube. It'll take me about an hour or so, and then I'll be sharing it with you all. Thanks.